The topic is Hamilton cycle. Here we will consider the graph. Graph will be having vertices and edges. In nothing but in the Hamilton cycle we have to cover all the vertices and reaching to starting vertex is nothing but a Hamilton cycle. Here you can see here the definition of Hamilton cycle is nothing but a Hamilton cycle is a Hamilton circuit. In this, by covering all the vertices in the graph exactly once and reaching to the starting vertex is nothing but a Hamilton cycle. The definition of Hamilton cycle is nothing but here you can see here a Hamilton cycle also called a Hamilton circuit. In this Hamilton circuit is a graph cycle that is covering all the vertices through a graph that visit each node exactly once. A graph processing a Hamilton cycle is said to be Hamilton graph. Here the another definition for the Hamilton cycle is nothing but a cycle that uses every vertex, that is nothing but every vertex exactly once is called a Hamilton cycle, and the path that uses every vertex in a graph exactly once is nothing but a Hamilton cycle. The definition of Hamilton cycle is nothing but in a graph that is covering all the vertices exactly once and reaching to the starting vertex is nothing but a Hamilton cycle. Here this is the definition. A cycle that uses every vertex in a graph exactly once is called a Hamilton cycle, and a path that uses every vertex in a graph exactly once is nothing but a Hamilton cycle. Another one is nothing but by using the help of a backtracking we solve the Hamilton cycle. Here you can see here a backtracking is an algorithm technique for solving problems recursively by trying to build a solution incrementally, that is one piece at a time. If you are not generating the correct solution, then removing that part. Here you can see here removing those solutions that fails to satisfy the constraints of the problem at any point of time is nothing but a backtracking. Here you can see here backtracking is nothing but if you fail in one of the case, then we will move to the backward direction and repeat the process, that is by covering all the vertices, then we will repeat that one. Here you can see here the diagrammatic part. Therefore, Hamilton cycle or graph considered in the Hamilton cycle is nothing but here you can see here A, B, C, D, E, F. Here you can see here A, B, C, D, E, F is the graph we have taken. Next one you can see here that is the starting vertex is nothing but A is the starting vertex. A is the starting vertex. Next in the A adjacent to vertex that we are having the B vertex, next C vertex, next one D vertex. Here you can see here A, B, C, D. That is A vertex we are having the adjacent vertex that is B, C, D. Next one. Next to adjacent to B, here you can see here B adjacent to that is C is the another vertex. Next one is nothing but E is the another adjacent vertex. Next one. The adjacent vertex to C. C here you can see here C we are having that is D is another adjacent vertex. Next one D is the another adjacent vertices. D and E is the adjacent vertex to C. Next one here we are at D. Next D we are having two adjacent vertices, that is nothing but E, and next one F is the adjacent vertex to D. Here you can see here E and F. Next one you can see here E to E we are having the adjacent vertex that is nothing but F. To reach A, that is to reach A, is there any possibility or to generate the solution set? No. That's why this is the case we have failed in the Hamilton cycle path. Next one back. Back is nothing but here we are moving to this one, that is D to E. E from E we are having only one adjacent vertex that is nothing but E, that is already covered. Next we will move backward to that is E to D. Next one. From D, what are the adjacent vertex to E? You can see here. That is nothing but you can see here. From D to F, we are having one vertex. Next one. Next one. From D, we are having already E is covered. Like this, we will continue the process, and by covering all the vertices, that is A to B, or next one B to C, next one D to C to E, next one C to D, next one E to F. Like this we will cover the adjacent vertex and generate the solution set for the Hamilton cycle. Here you can see here the same circuit, the solution set for the Hamilton cycle. Here you can see here, from starting we are having the vertex A adjacent to, that is we are having B, C, D, we are having the adjacent vertex. That is, here you can see here, from A we are having the adjacent vertex, that is nothing but B is the adjacent vertex, B is the adjacent vertex, next one C is the adjacent vertex, next one D is the adjacent vertex, B, C, D. Next one, from B we are having the adjacent vertex, that is nothing but C, and E is the adjacent vertex. Next one, you can see here, from C we are having the adjacent vertex D. Next one, from D we are having the adjacent vertex E. Next one, from E we are having the adjacent vertex E. Next one, this is the fail condition. Next one, after moving this one, next one we will change this one. You can see here, from E to A, reaching to A is not having the possibility, that's why this case is also failed. Next one, backtracking, from here to here we are moved from to C. Next one, from C we are having the adjacent vertex, that is nothing but E. E is the adjacent vertex, that is D and E. D, it is not generating the solution. E case you can see here, E. From E we are having the two adjacent vertex, that is nothing but D and EF are the adjacent vertex. D and F are the adjacent vertex. Next one, from D we are having only one path, that is nothing but F. To reach to A is another possibility. Is there any possibility? No possibility is there. That's why it will not generate the solution set. Next one, here you can see here, you are at E. Next one, to E we are having adjacent vertex, that is D is covered. Next one is nothing but F is the adjacent vertex. Next one, from F we are having the adjacent vertex, that is nothing but only one, that is nothing but D. Next one, from D we are having only one adjacent vertex, that is nothing but A. That is, here you can see here, in this path we are covered all the vertices, that is nothing but A, B, C, D, E, F in the path. You can see here A, B, C, next one D is covered here, next one E, next one F, next one, covering all the vertices and reaching to the starting vertex is nothing but a Hamilton cycle. Here you can see here, this is the condition, this is nothing but in this case the case has been failed. Next one, in this case also the direction, this is also failed phase. Next one, third path, this also case failed case. Next one, here you can see here, next one is nothing but this is the fourth one. You can see here, starting vertex is nothing but A. Next one, after it is travels to the vertex, that is nothing but B. Next one, from B the adjacent vertex is nothing but C. Next one, from C we are having two adjacent vertex, that is nothing but D and E, but we are selecting, this is the failed case, that is this case and this case is failed case. That's why we are moving to another path, that is nothing but from E adjacent we are having D and E. This is also the failed case, that is nothing but not covering all the vertices and not reaching to the starting vertex. That's why this is also the failed path. Next one, you can see here A, B, this is the starting vertex A, next one B, next one C, next one is nothing but E, next one F, next one is nothing but D. Here you can see here A is nothing but this is the A, next one B, next one C, next one D, next one E, next one F, next one reaching to the starting vertex, that is nothing but by covering all the vertex exactly one and reaching to the starting vertex is nothing but a Hamilton path. Next, by considering this another example, by using this we can solve the Hamilton circuit, that is you can see here. Find the Hamilton circuit for the graph. Here the starting vertex is nothing but A, that is nothing but you can see here A to B directly traverse to A to B, next one is nothing but you can see here B to C, next one C to E, next one is nothing but you can see here F, next one G, next one by covering the D also we have to traverse. Here you can see here starting but the Hamilton path for this graph is nothing but from first starting with A, then traverse to B, next traverse to D, next one traverse to A, next one traverse to E, next one traverse to E, F, next one traverse to G, next one reaching to the starting vertex is nothing but a Hamilton path. For this example you can see here the Hamilton circuit for the following graph is nothing but starting vertex is nothing but A to B, traverse to A to B, next one B to D, next one D to C, next one C to E, next one E to F, next one F to G, next one G to A. By covering all the vertices and reaching to the starting vertex is nothing but a Hamilton path.